Okay, we're going to look at binary number systems. Binary number system is a number system that incorporates just two characters or something. Technically, that could be something like a happy face and a sad face, and they could both represent two things. Binary is just like a bicycle, the idea of two wheels, so that's what binary stands for. Those symbols could be happy, sad face, anything you want. In machine language, so for computers, they're technically a 0 and a 1. So 0 represents essentially off, and 1 would represent on. So sometimes in computers they have things that are like logic gates, so like 0 is off, 1 is on, or vice versa. It depends how you program the system. Each of these, or this language itself, can represent many, many different things. So binary, let's say we have 2 place or 3 place values. So I'm going to use these squares to represent a place value. So here's a 1 place value, 2 place values. Well, let's say I had to represent, we'll say, the decimal number system. So I guess to make sense of this, it's important to explain it in terms of our number system. When we say decimal, we have 10 digits, okay? So decimal system, we'll do in black here. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. That's technically 10 digits there, okay? In binary, if you were to represent this, it would kind of look like this. You'd have 0 for 0, 1 for 1, and then 1, 0 for 2. Now it looks really similar to 10 for us, but they only have 2 characters to represent numbers with, okay? And look at this. You'll notice they're now using 2 different units, or 2 different place values, sorry, is the word we're talking about. So to represent 3, I would say 1, 1. To represent 4, I move into the third place value, 1, 0, 0. To represent 5, I go 1, 0, 1. To represent 6, I go 1, 1, 0. 7 is 1, 1, 1. 8 is fourth place value, 0, 0, 0. And 9 is 1, 0, 0, 1. So if we read these as if it was the decimal system, this looks like 1001, 1111, 110, 101, 100, 11, 10, 1, 0. But all number systems are based off of place values, okay? So our place value here, we usually called the ones. We used to call this the tens. We would call this the hundreds. Not that we used to. So in decimal, this is our ones. This is our tens. And this is our hundreds column, right? H-U-N, there you go. Spell hundreds. Yay, I'm special. And the next one, they would use different place values. You know what? I don't know off the top of my head what these place values would be called, but these are the numbers they would represent. In the ones column, okay, we have either a 0 or a 1. That only represents 2 numbers, okay? In the, I'm going to have to call it something else. We wouldn't call it tens. I wonder what other word you would call it. I'm not sure. In the second one, we're just going to call it our second one here. So we'll call this the first place value, the second place value, and the third place value. In the second place value, again, we only have 2 characters. You can either be a 1 or a 0. Same with the third, a 1 or a 0. So to represent as numbers get larger, the binary digits, the place values really start to increase. They become much, much larger. Okay, so we have to realize is we're not dealing with a system like that we're used to dealing with has 10 digits. We're dealing with a system that only has 2 digits, so you have to represent everything possible with just these 2 digits. Shrink this a little, okay? So if I'm going to do that, let's talk about adding and subtracting, okay? Maybe this will help make sense of the system a little more. So if I have 1, 0, 1, 1, okay, and looking at a reference chart, we don't actually know what that represents yet, okay? And I wanted to add, let's say, 1, 1, 0, 0. This becomes a little difficult to add. We're used to, actually no, it's not the hardest. Let's say we're going to add these digits together. Well, 1 and 0 is 1. That works out really nice. 1 and 0 is 1. 1 and 0 is 1. In decimal, 1 and 0 would be 2. But this character doesn't exist in binary. Okay? So this is where carrying starts to happen. So it wouldn't be 2. We have to carry a digit. So we'd have to carry the value of 1 over. This would become 0, and then it'd be 1 down here. So it looks really weird when it comes to adding. Another way you could think of this is by using dots. Okay, so 1, 2, 3. There are 4 place values here. Okay, we're going to call this the first, the second, the third, and the fourth. The first number here, we'll use dots to represent the values. There's 1 dot here, 1 dot here. There are no dots in the third place, and there's 1 dot in the fourth place. Well, I'll use green to represent what we're going to add to it. Okay. In this system, we're going to add no dots to the first one. Okay. No dots to the second. We're going to add a third dot here. Sorry, we're going to add 1 dot in the third place value, and we're going to add 1 dot to the fourth place value. Okay. So when we go to add or figure out what our answer is, we just count the dots in each of the place values. Well, there's 1 here, 1 here, 1 here. We've encountered a problem. We can't have 2. 2's not a digit. So what this is we take this value and we bring it over to the next place value, the 5th place value. So the 2 of these would represent 1 dot in this place value. So the 2 of them are now gone from here. So there are no dots here, and there's 1 dot here. Okay? This is how we talk about addition of binary numbers. Remember, there could only be a max of 1 dot. As soon as we have another dot in a place value, it has to carry over and get moved or represented by 1 dot in the place value to the left of it. So here's a more difficult question, let's say. So let's shrink this one a little. Shrink all of them. Let's say I want to add 1, 1, 1, 1, 1 plus 1, 1, 1, 1, 1. Here we go. Now we're getting into some tricky stuff. Okay? Before I add it up like this, because this is technically these are characters, okay? Let's actually use counters, and that's what I was doing with these place values here. Call this our counter version, okay? How many did I have? 1, 2, 3, 4. I had 5 place values. So 1, 2, 3, 4, 5, okay? We represent an amount in each of these as 1 dot. So 1, 2, 3, 4, 5. Great, there's 5 dots there. We're going to add 1 dot to each of these. Well, I'm going to put a green one in here, 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 and a green one in here. Well, remember, we can't have more than 1 dot. So what's going to happen? Well, this pair has to move over to the next place value, and I'm going to write these in here as a reference. Second, third, fourth, and 5th place value, okay? This gets represented as 1 dot in the next one. Think of it as if you had, in the decimal system, you had 5 plus 5. Well, 5 plus 5, we don't have a number larger than 9 to fit in one of the place values. So it becomes a 1 in the next place value, and we have 0 left over here, and then we have 1. So 5 plus 5 represents what we call 10. Okay? So same thing is happening here. Let's say again, let's say we had 6 and 5. Same concept. Still 11. We don't have a character that represents 11, so we have to put down 1 in the next place value, but we still have 1 left over, right? So we still had 1 left over in this column, so we put a 1 here. We could show that with dots too, but we're going to use it in the binary system. So these two represent 1 dot in the next column. So now I have 1, 2, 3. Well, I can only have a max of 1, okay? So these two have to come over, represent the dot here, okay? This dot is still in this column, okay? So right now there are no dots in this column. We moved them all over in the first column. In the second column, we moved over 2 of them. We still have 1 left, so there's still a 1 value there. In the third column, I still have 3 dots. So I take 2 of them. What would I do with these 2?
Move it over.
Move it over. Represents a dot in the fourth column. I still have 1 dot left over, so that represents 1 here. I have 3. I can't do that. I have to take 2 out, move it over, becomes 1 dot in the next. I still have 1 dot left over. I bring it down. Same concept, 2 to the next place value. Great, 1 dot there, so it becomes 1, 1. So in binary, which seems very different from our decimal system, when you add 11111 plus 11111, you get 111110. Not with it, technically what the answer is. Same idea as decimal, just that our topping value, you know, we can get up to level to number 9 in decimal, and then we have to go to the next place value. That's what 10 represents. We can only get up to 1. And then as soon as we get to 2, we have to move a value over, okay? Okay, so let's try that.